In this lesson, we will talk about solving absolute value equations and solving inequalities. First, let's talk about absolute value. If I just gave you the absolute value of x equals 4, and I asked you what values of x would make that true, you would say that x can equal 4 because the absolute value of 4 is 4. But you would also tell me that x could be negative 4 because the absolute value of negative 4 is also positive 4. So this equation, the absolute value of x equals 4, has two solutions, 4 and negative 4. To solve an absolute value equation, we will isolate the absolute value, and then we will split it into two equations, one equal to a positive and one equal to a negative. When we solve, we get two answers. So in number 1, the absolute value is by itself. So we can take the stuff on the inside of the absolute value and we can say x minus 4 can equal positive 7, because when we take the absolute value we would get positive 7. We can say that x minus 4 can equal negative 7 as well, because if we took the absolute value of negative 7 we would get 7. Let's solve both of these equations. In the first one we add 4 and we get x equals 11. In the second equation we add 4, but this time we get x equals negative 3. There are two solutions to this absolute value equation. Number 2, we have to first get the absolute value by itself, so we will subtract 1 from both sides. We get the absolute value of x equals 3. So what values of x make this true? Positive 3 and negative 3. Because the absolute value of 3 is 3, the absolute value of negative 3 is also 3. Two solutions. Number 3, we have to isolate the absolute value first. So the first thing we're going to do is subtract 1. We will then get rid of the 2 by dividing both sides by 2. So now, when we take the absolute value of the stuff on the inside, we can take the absolute value of 5 to get 5, but we can also take the absolute value of negative 5 to get 5. So we will take 2x plus 1 and set it equal to positive 5. We will also take 2x plus 1 and set it equal to negative 5. We will solve both of these equations. So subtract 1 and we get 4. Divide by 2 and we get x equals 2. In the second equation, we will subtract 1 and we get 2x equals negative 6 because you're becoming more negative here. Divide by 2 and you get x equals negative 3. Again, we get two solutions. The only time that you're only going to get one solution is if you have an absolute value set equal to 0 at some point. Okay, so please take a moment and complete the checkpoint problem and input your answer. Okay, so everything we've done so far has been an equation. Let's talk about an inequality. When you solve an inequality, we are solving something with a less than sign, a greater than sign, a less than or equal to sign, or a greater than or equal to sign. We will isolate the variable just like normal, but we will have to flip the inequality if we multiply or divide by a negative. So let's look at number 5. Number 5 says solve for x and then graph on a number line. So the first thing I'm going to do is just solve for x. So I'm going to subtract x from both sides. And then I'm going to add 4. And I get x is greater than negative 1. It says to also graph on a number line. So let's talk about graphing on a number line. If the inequality is less than or greater than, we will use an open circle. If the inequality is less than or equal to, or greater than or equal to, we will use a closed circle. that means that the point that the dot is on is included in the solution. Shade the number line. So, if we want x is greater than -1, we will have an open circle on -1, and we will shade where the greater than numbers are, or the larger numbers. The numbers that are bigger than -1 are to the right, so we will shade to the right. In number 6, this is called a compound inequality. It says 2x is less than -4, or -3x is less than or equal to -9. We solve these inequalities separately, but we will graph them on a number line. To solve the first inequality, we will divide both sides by 2, and we get x is less than -2. When we graph that, it will have an open circle on -2 because it's just less than. We want the numbers that are smaller, so we will shade the number line to the left. Let's solve the second inequality by dividing by -3. Now when we divide by a negative, we will need to flip this sign so that it's greater than or equal to a negative divided by a negative is a +3. This will mean that we need a closed circle on 3 because 3 is included in the solution. So x is greater than or equal to 3. So we want 3 and anything bigger. When you have a compound inequality that is or, and you graph it on our number line, the shading should go in opposite directions. Number 7. This is also a compound inequality. This is called an AND inequality. So -3 is less than 2x plus 1 is less than or equal to 9. That means that 2x plus 1 is less than or equal to 9, and it is also greater than -3. When we solve this, we have to solve all 3 pieces. So first, we're going to get the 2x by itself by subtracting 1 from all 3 pieces. We get -4 is less than 2x is less than or equal to 8. Now we will divide by 2. Again, we will divide all 3 pieces by 2. So we get -2 is less than x is less than or equal to 4. So let's begin with the 4. We will have a closed dot on 4 because 4 is included in the solution. This will shade to the left. That's where the less than numbers are. Then we will have an open circle on 2. 2 is not included in the solution set. We want x is greater than -2. That means we will shade to the right. Now what you should notice is that there is some shading that overlaps. I will darken in that shading because that overlapped area is where all of the solutions occur. So when you graph an OR inequality, the shading should go in opposite directions. When you graph an AND inequality, there should be shading that overlaps in the middle. Okay, you have 2 more checkpoints. Please show your work on your note packet and submit your final answer.